Hello and welcome to this lesson, which carries on the coasts topic that we've been studying so far. This next one is going to be about a feature that we have on certain landscapes called estuarine mudflats. You might also know them as salt marshes as well. So what we're going to be looking at today is predominantly what salt marshes are, how they form, and where we find them, as well as how humans use them. So there's a bit of a crossover here to sort of development and why and how people live in coastal environments. Okay, so yeah, estuarine mudflats and salt marsh environments. So here you can see a bit of a mudflat. As you can probably guess, in a mudflat there is a lot of mud. Some of the mud, as you can see in this picture on the right hand side, has been colonised by grasses and other species like that are quite small. They're quite low to the ground. They're really well adapted to live in these environments. Now, the key point about salt marsh is it's very salty, so the plants that live here have to be adapted to the salt water. They have to be adapted to being submerged at high tide. So almost anything on the right hand side of the picture in the lower bit will be submerged at high tide, and those plants need to be adapted for that. As you can see, the bits on the left above the cliff areas, they won't be submerged at high tide, so we get more sort of stable grasses there. But yeah, that's sort of an image of a mud flat. You can see in the background you've got the river, and we'll come on to explaining the role rivers play in mud flats later on. Okay. So here's another image of a salt marsh mud flat, and you can see here it's characterized by a big area of flat mud. So they're pretty much exactly what they say in the name, mud flat, an area of flat mud. This one has got slightly different grass types, as you can see, slightly longer. Now these grasses will be what we call halophytic, which means that they can survive in salty conditions. And that's because these will be submerged from time to time, maybe with a spring tide once or twice a month, roughly. So they will most of the time be out of the water, but they will occasionally be covered. And you can see that there's nothing growing on the mud area, which tells us that it's quite a hostile environment. That not a lot can survive there. So again, this will be submerged probably 2 times a day, I should imagine, maybe even more depending on the tidal range of the area. This third image of a mudflat is slightly different because it's got some human management going on here. So you can see the fence in the foreground, you can see the golf course is the greener grass in the background, and in between that you've got the areas of mudflats, some of which has been colonised by grasses. Now the areas colonised by grasses will be the least hostile bits, so they'll be the bits that are exposed most of the day from the water. They're probably only covered by the water a couple of times a month, so most of the time the plants they're fine to live there. And then you can see the areas in between where they've got no vegetation on. Those are the areas that will be covered at high tide. Those are the areas that will be underwater quite a lot, and the conditions just aren't right for plants to survive there. So you can see from the images, we can tell quite a lot about salt marshes and mudflats from just looking at them, really. This is a satellite image of a mudflat that some of you guys might be familiar with. Now, I don't know if many of you recognise this picture, but it's of Dawlish Warren. So on the right hand side you've got Dawlish Warren, on the left hand side you've got Exmouth Marina, and the spit stretches out. Which way does it stretch? It stretches out from Dawlish into the mouth, across the mouth of the River Exe. I've labelled the river and I've labelled the sea on there so you can see which is which. Now I've also labelled a sheltered area on there, which is the mudflat itself, and basically what happens is that area is sheltered from the sea by the spit in front of it, and it's also sheltered from the main flow of the river, as you can see there. And as it's a sheltered area, it's going to have a lot less energy. Any water that goes there is going to have a lot less energy, so there's going to be a lot of deposition, and that's essentially how the mud builds up, is that the water is low energy there, it deposits its material, and gradually this area of mud will build up. Now that will still be covered maybe a couple of times a day at high tide, but it will be exposed most of the day. So if you ever get the train to Exeter, as you go past Dawlish, look on your right hand side and you'll see the mudflats if it's low tide. They're quite a big area and there's quite a lot that goes on there. So in order for a mudflat to form, you need an area that's sheltered from the sea, sheltered from the main current of the river, where there's low energy and deposition can occur, and crucially the sediment can build up over time. Because if it wasn't a sheltered area, deposition could occur, but then the next time the water came in, that material would be washed away. Okay, so it needs to be really sheltered, really quiet area in order for the mudflat to build up. Okay, so this one shows a cross-section of the sort of the timeline of salt marsh development. So we're going to start with the low marsh. Now, eventually the low marsh will become the uplands bank if the situation allows it. So imagine this is like a timeline. We start on the left, we work our way to the right, and I'm going to talk you through each stage. So with the low marsh, you can see it says regular inundation. Now that means this area is regularly submerged by water, and you can see that with the mean high tide watermark where it covers the whole area. Now this means that every plant or algae that survives there will need to be able to survive living in salt water for long periods of time. And there's not many species that can do that. We often call these species pioneer species because they're the ones that can survive the really hardy, really difficult environments, and they sort of lay the foundations for what's to come later on. So in the low marsh area you get the pioneer species like the algae, like some really fine grasses that can survive there, and they are adapted to survive in the salty conditions in the low marsh area. Now over time, what will happen is the algae and the grasses that can survive there will mean that the water gets even slower, so there's even more deposition. And what happens, as you can see as we move to the salt meadow, is the layer of mud has actually got higher, and that is purely because of the grass trapping the water, trapping the sediment, and making the mud layer build up. Now that has another effect as well, in that the area gets slightly more fertile because it's got the biological material from the grasses and the algae that's built up over time. So as we go from the low marsh to the salt meadow, the mud gets deeper, it gets more fertile, and as a result more plants, a wider range of plants, can live there. And as you notice as well, it's no longer submerged at high tide. So this as well is going to benefit it because the area is going to be less salty. So the plants that can survive there have got a less salty, more fertile environment to live in. So they need to be less resistant. And this leads to the pioneer species being outcompeted. They can't live there anymore because these other plants move in because it's a nicer environment. Going further right, we get to the salt pan. Now you can see here, again, the area's been built up because whatever tide is coming in, like it says 1.5 times tidal range, that would be during a spring tide, that traps even more sediment in amongst the species in the salt meadow, and the mud builds up even higher and it gets even more fertile. So then you can get plants with maybe flowers and bigger leaves starting to live there because the area is even more suitable now for them. So again, as we get further inland, the amount of times it's covered by seawater decreases, the height increases, and we're left with an area eventually where it's never covered by seawater. And as you can see, we get bigger plants and even trees growing in here. And what we call that is the climax vegetation. So the upland bank will be the climax vegetation. It means it's the dominant type of plant that can live there. So if for the UK, climax vegetation is kind of like oak woodland. There's no interruptions. It's not covered by seawater at all unless in really, really extreme events, say like a massive storm or anything like that. And yeah, the plants can just live there without interruptions, without worrying about what's going to happen. So some key points from this one. As we go from the left to the right, the mud gradually builds up. It becomes more fertile. It becomes less salty, so more plants can survive there. I know that was quite a lot of information, but if you follow it stage by stage, the changes become quite clear, okay? So carrying on from the last slide, I've kind of put it in a bit more of a simple timeline here for you to follow. So as we go from a mudflat to a salt marsh, you can see the starting point is we need a sheltered bit of water that lacks energy where deposition can occur, and that links to what we said about Dawlish Warren. Eventually, because the area is sheltered, mud, fine sand and silt, so that's all very, very small sediment, will start to build up in these areas and you get the layer of mud forming. The more material you add, it's going to reduce the depth of water until it's shallow enough that species that we call halophytic, which means they love salt, they can survive in high salt environments, they can survive there, even going underwater twice a day. Number 5, the roots of these halophytic plants, they start to bind the soil, that binds the mud together. They start to add nutrients to the soil, and eventually the soil builds up and the mud builds up so much that we get onto the salt meadow and salt pan stages where more and more plants can survive there. So gradually the area is submerged less and less and less because the mud has built up and up and up, until it's only reached by spring tides and storms. So that's essentially a process that we call succession, which is where one area is colonized. The conditions there are really harsh to start with, but the colonizer plants make the conditions nicer by adding biological material to the soil, making it more fertile, and then more species can move in and move in and move in, and then eventually we end up with this climax vegetation where there's no more interruptions, and the area is quite stable. Okay, so some key words there is succession, which is where one habitat changes over time to form a climax vegetation. And then we've also got things like your high tide mark and things like that. Okay, so what I've got here is I've got some of the species that can survive being submerged or partially submerged at high tide. They've all got one thing in common, which is they're all quite tall, grassy style plants. They don't have many flowers, they don't have many big leaves, because that wouldn't help them in this environment. So I've got a few here like samphire. Any of you that are into your fine dining might be familiar with samphire. It actually comes from coastal mudflats, that's where it's harvested. Sea aster, eelgrass, spartina. So all of these species can survive being underwater. They can survive the really, really salty conditions, and they bind the mud together. When we come on to looking at the next slide, which is the plants that can survive further into the succession timeline, they look very, very different. So key points: these are all grassy style plants. They've got very few big leaves, and they're all specially adapted to survive in the salty conditions. On the left here you can see the cross section of a leaf of marram grass. Now if you're wondering what marram grass is, there's a picture of it in the bottom right. If you've ever been to a sand dune, you've probably seen marram grass before. The key points are though that it's a really, really curved leaf. Now if you remember back to GCSE biology, all those fun years ago for you guys, the stomata, which let water in and out of a leaf, are all wrapped up and protected on the inside. And you can see the stomata, they are the green bits highlighted on the diagram. So they're all really, really protected. If you notice as well, there's little fine hair-like structures that keep the water in even more. So they reduce the amount of water being lost to the wind. Because if you imagine the wind will blow around the outside of the leaf, it won't go into the middle of the leaf, so the leaf can keep water in there. If the leaf was flat, it would just lose so much water and the plant would die. So it's really, really adapted to survive in these environments. If you ever get a piece of grass, you can unfurl it, because normal grass is like this as well. But yeah, marram grass really, really well adapted. It's got really, really tight curved leaves with all the stomata in the middle, so it reduces the amount of water lost to the wind. So contrast what we've just seen on the previous slide of all the grasses to these two images, which are further inland from the salt marsh, so further into the succession period. Now these areas, they're submerged less and less and less and less. The sediment has built up more and more and more and more, and as a result the plants there don't need to be as stingy as the plants in the submerged areas. So you can see they're slightly bigger, they've got more sort of colour to them, they can afford to have flowers because they can put energy into that because they're not having to be worried about submerged all the time. The soil quality is better, so they can grow bigger, and yeah, the plant coverage becomes thicker as well. So you can see in the picture on the left, you can barely see any of the mud, which shows us that there's obviously a lot of fertility there because the area is covered up with lots of plants. So there's more plants, meaning it must be more fertile. So the top bullet point is just a reminder that they occur in sheltered water, usually behind spits and bars, along the banks of river estuaries where tidal currents are slower. So slower means low energy, means deposition, means eventually a mudflat can build up and form. So if we think about humans and mudflats, what are the benefits of having salt marshes and mudflats around? Well, they're very, very productive ecosystems, which means they are fertile, you can grow a lot there. So some coastal salt marshes are actually used for farming. They act as a coastal defense, so they're like a natural barrier to things like storms, even hurricanes in some areas. so that's a benefit of them as well. Some species only live there. So again, if we're into conservation and preservation, we need these habitats because some species can only be found there. Thinking back to the water and carbon cycle, so a really good link here is carbon absorption. They are a carbon sink, salt marshes, so they absorb a lot of carbon, they can store it there. They help with nutrient cycling, so recycling of dead material into new material, and also they trap coastal sediment, so they act as an area of deposition. So if you think about those, that's actually going to be worth probably billions of dollars to an economy. Because you can grow things there, it acts as a coastal defence, so you don't have to spend millions of dollars on that. It might attract tourists to an area and things like that as well. So they're really important, but there are some problems facing them. So lots of salt marshes around the world are being destroyed by people to make way for other things. Yeah, some of them are even being replaced by like farmlands and things like that, which eventually you might get 1 or 2 harvests out of them, but similar to the rainforests, they will just be drained very quickly. Another risk is of course global warming. So as temperatures get warmer, it means the environment gets even more hostile, so less and less can survive there. Linked to global warming, we've got sea level rise, so the sea levels are going up. Hopefully that's not breaking news to you, considering we studied it in right at the start of the year. And obviously, as sea levels go up and the geothermal expansion of water, it means, sorry, not geothermal, just thermal expansion of water, it means that the sea levels are going to get higher, more of the salt marsh is going to be underwater for more of the time, and that's really going to affect some of the species that live there. And urban development, some of these are being replaced with housing developments, which is not the most intelligent idea, is it, to build on an area that's inundated by the sea on a regular basis? But you know, as humans, we can be a very stupid race sometimes. And remember, just a reminder, what's the environment like? Flooded twice a day in most bits. Most of the salt marsh will be flooded during spring tides. It's favoured by salt-loving plants, which are called halophytes, and they're formed by the deposition of sediment, and they're usually colonized. Remember, a colonizer species is the first species that moves in on an empty territory or an empty habitat, such as mudflats. And they can survive in harsh conditions. So yeah, that's basically a summary of salt marshes there for you. Okay, so one final point to think about is just for each of these points here. So I've put a list of 7 threats to salt marshes on here. So a bit of a review and a bit of independent thinking for you guys. For the 7 points, just want you to develop them to say how each point is going to affect salt marshes, okay? And then just submit that to the Google Classroom, and yeah, we'll review them and sort of go through them on there. All right, thanks for tuning in again. Hopefully you now understand how a mudflat develops, how it forms, why they're useful, what plants live there, and the threats facing them. Okay, thank you guys, and I will speak to you all soon. Thanks, bye.